before we get into homework, and I definitely am going to go over at least question 14 a little bit on the homework. But before we do that, I wanted to take a minute and just talk in general when you read about ChiSquared. And this is pretty important stuff, so if I was going to write something down today, this is probably one of the things I definitely would. On your quiz that you have on Friday, part of it will be to identify which chi-squared test you need to use, okay? And I believe that there were the last 3 questions on the just checking were like that as well, right? Where you had to identify, is it an independence or a homogeneity or a goodness of fit. So I kind of tried here to clearly explain what the difference was, okay? The first test that we talked about with chi-squared was, in fact, a goodness of fit test. It deals with one sample, okay, and there's one qualitative variable. It might have many categories, but there's just one. Remember we use lists in the calculator. We use the list feature. So in this particular one, you use the lists. And remember, it was the chi-squared GOF test on the calculator, right? So that's the one where you enter the data into list 1. You're observed into list 1. You're expected into list 2. And you do the goodness of fit test. One sample, okay? We briefly introduced the second one, which is the homogeneity, last class. And we're going to finish that example today. Remember the St. John's wort, the depression example that we ended with in class last time? We're going to start with that in just a couple of minutes. But homogeneity is, again, one variable, okay? But you might have 2 or more independent samples that measures that variable, okay? So, for example, in the depression question we talked about last class, you had 3 treatment groups. And we'll look at those 3 treatment groups in a couple of minutes. You might also be looking at different years, the amount of rainfall that occurred. Well, should be qualitative data. So the number of days it rained in 2007 and in 2016. Okay? Can you compare those? Comparing those counts. That's a homogeneity situation. Is there any difference amongst the groups, the treatment groups, or the years? Independence is the final one, and we'll look more closely at that today. Independence has 2 variables, and they're both qualitative. So it might be something like, is there a relationship or is there an association between hair color and eye color, for example, where you might look at both, 2 different some scenarios with that. But you're really looking at the independence or dependence amongst 2 qualitative variables. So there's 2 variables. That's the key in that situation. Oftentimes, they will use the word independent in the problem. Are they independent? On the FRAPI, we didn't flex today, and this only goes for Block 6 because Block 2 hasn't done the FRAPI yet. But the one where I think the question said, was there an association between, right? But it still implied an independent situation. On the calculator, we're going to do this today as well, you're actually going to be using matrices. Okay? And so I'm going to show you how to do that. You're not going to use lists anymore because the information is provided to you in a 2-way table often. Okay? A contingency table where you have columns and rows. So you're going to use a matrix. And you're going to use just the regular chi-squared test, not the goodness of fit, but you'll actually use the same test on the calculator for both of these. Okay? So if you're given a contingency table, you know you've got to use a matrix. Okay? But we'll look at these last 2 in more detail here today. Okay? What I'm going to do is I'm going to put up the problem that we started with last class. And I'm going to have you, from beginning to end, now that you've read about it, now that you've identified what homogeneity is, we started it anyway, but I just want to have you finish this problem. I want you to do all 4 steps to the best of your ability, and I'm going to call on certain people to write the hypotheses, to write the conditions, to look at the chi-squared test statistic, the p-value, conclusion, etc. But before I do that, I wanted to talk to you about how to find the expected values. Okay, and then I'm going to check homework in a minute. What values are given in this problem? What is that matrix or that contingency table that you see there? They are the what values? They're the observed values. Okay? And anytime you're doing a chi-squared test, by the way, what tells us this is chi-squared? We did this last class. Who remembers? We have a contingency table that has what inside of it. But what kind of numbers are these? Are they percentages? They're counts. Okay, so that's important. And what kind of variables do I have? Qualitative variables. Why is this homogeneity? Think back to what I just said. Homogeneity means I have two or more samples that are independent, and I have one variable. Is that what's happening here? What is the variable? Whether depression came back or not, right? That's what I'm measuring. And then what else am I measuring? Oh, I'm sorry, that's what I'm measuring. Do I have independent samples? The 3 treatment groups are my samples, right? Anytime you have an experiment, the treatment groups are your independent samples. Okay? So how would I find the expected values? Well, we're going to look at the variable that I'm measuring. How many total people did I have depression return for? In my whole experiment, how many people had depression return? 60. When I add 24, 22, and 14. Would you agree? That's 60 total. How many people did I have no sign of depression return for? If I add the 6, the 8, that'd be 30. Now, if I'm just talking about what I expect to happen, I have 60 total people where depression returned. How many treatment groups did I have? 3. So how many would I expect if there was no difference amongst them? There'd be 20 in each treatment group. So my expected first row is going to be 20, 20, 20. Because I had a total of 60 with 3 treatment groups. Okay. How about what my expected would be in the next row? I have a total of 30. Again, still 3 treatment groups. What would I expect to be in that? 10. So this is going to be my expected. And sometimes, actually often, I want you to start there. Because you need that for several things. You need this to check my conditions. What else do I need this for? Help me find the degree of freedom, but I don't need I can do that from the observed. To find chi-squared. Isn't it observed minus expected squared over expected? So I need this to find the chi-squared. Okay? So I wanted to at least get you started with that. So I'd like for you to do all 4 steps of this. Hypotheses, conditions, show me the chi-squared value, show me the p-value, and the conclusion. Question? Yeah, because there were 3 treatment groups. 1, 2, 3, which is the 3 independent groups. So that's why I was 60 divided by 3. That's how that came about. And this one was 30 divided by 3. Okay, good. If there were only 2 treatment groups, I'd divide by 2. Okay, good question. All right, so I'm going to pause here. I am going to ask you to come up to my desk and show me your homework. So while you're working on this. Fair enough? Well, we're going to start anyway. Ready or not? Here we come. Okay. Can someone tell me what the null hypothesis is going to be in this situation? Yes, ma'am. There's no difference in the treatment groups. Perfect. And there are 3 treatment groups, so there is no difference amongst the treatment groups. And how about the alternative hypothesis? Maddie, you want to just go ahead and finish it off? There is a difference. And I don't know which one is the one that sticks out. This test does not identify the treatment group that works or doesn't work. All it says is that there is a difference amongst them. Okay? Perfect. All right, so that's step 1. How about step 2? Who wants to volunteer to do step 2? Go ahead, Byron. A chi-squared what test? A what test? I just can't hear you. That's all. I mean it because like I've had shingles on my eardrum and I actually can't hear. I'm partially deaf. Homogeneity, yeah. And as we learned, by the way, this is only for 6 blocks. Block 2 hasn't done it yet, but they're okay with just saying chi-squared, right? And if you say the wrong one, after that they take off. But if you just say chi-squared, full credit. Nice, okay, whatever. But it is a chi-squared test for homogeneity. Will I be as nice? No. Okay, you have to tell me which one. Sorry. On Friday's quiz, you have at least 3, well, let me tell you the format of the quiz. You have 10 multiple choice questions that are 2 points apiece, and then you have 1 free response question that is going to be a full hypothesis test from beginning to end that counts 10 points. So you have it's a 30-point quiz, okay? I'm not going to tell you which one of these 3 tests it is. It's one of these 3, okay? You'll have to do one of them. We've done goodness of fit, we're doing homogeneity, and we're getting ready to do independence. You'll have an example of each to study. You'll do one of these, but 3 of the multiple choice questions will be identify the correct test, okay? The first 2 problems in this chapter in the textbook have you do that as well. I'm not going to officially assign them to you, but it would be good for practice if you wanted to practice that part of the quiz, okay? So the first 2 questions in the back of the book. It is not just chi-squared, but do you know the difference between homogeneity and independence and goodness of fit? All right, what's the next part of part 2 or step 2? Anyone? Conditions. There are 2. How about the first condition? What do you think, Anna? So I can't just say random. What do I have to say? The second part's all you needed to say, okay? So that is correct. The subjects were, she said the word allocated, sounded fancy. So the subjects were put into the treatment groups in a random fashion. And it actually says that in the problem, I believe. Let's double check it. But it does say the subjects were randomly divided into the 3 groups. So that is the condition. So that should happen in any experiment, right? That's part of experimental design. So subjects were randomly put into treatment groups. Jessica, would you give us the other condition that we have to check? Yeah, and they are. We have our expected counts right here. They're all greater than 5. Actually, all this is checking, the expected counts, is that your sample's large enough. If my expected counts weren't 5, that just means I didn't ask enough people. So it's still that large enough condition that we've been dealing with all along. It's just written a little differently. So all expected counts are greater than 5. Good? Okay. And they are, because we checked them. We did that first, which is what we should have done. Step 3. Let's look at that a little bit closer. What do I need to do? Ayana, help me out. What is part of step 3? What do I need to do first? I see it on your paper. Okay, which is what? chi-squared the sum of squared over perfect. Okay, so that's our formula. Now we're just going to go ahead and plug it in. All right, at this point, I got my expected. I'll just kind of scroll up to look at my observed. It doesn't matter the order as long as you look at what corresponds to what. So the 24 and this 20. And then we'll go in each position and plug in our numbers. So 24 minus 20 squared divided by 20 plus. And we'll go from there. Okay? So let's plug all those in. And I do fully expect that you do all of those. I would not give you anything more than 6, because that would be a little much. Then we have 22 minus 20 squared all over 20. And then we have 14 minus 20 squared over 20 plus 6, 8, and 16. Got that wrong? All right. When you add all that up, Fernando, what'd you get for chi-squared? 8.4, and it's exactly 8.4. There's no rounding needed. It is, in fact, that, 8.4. Good. Perfect. We're still not done with this particular part of the hypothesis test. I have one more thing left to do, Lexi, and what's that? And how do I do that? All right, so I'm going to draw it first, okay? But you're right, chi-squared CDF. Tell me, I'm going to put what number on the chi-squared? Good. You know that it's always a greater than, doesn't really show direction. Tell me what I plug in. It could be some big number off to the right. And then, where'd you get 2 from? Where does 2 come in? Yeah, it's the degree of freedom. Remember, it's the rows, number of rows minus 1, which is 2 minus 1, times the number of columns minus 1. So it's 1 times 2, which is 2. So my degree of freedom is 2. Good. All right, and when we do that, what p-value did you get? 0.15, 0.1499 or something like that, right? Good, perfect. All right, so I'm done with step 3. I'm finally done. Josh, what do I do in step 4? And give me the first part of that, just because the conclusion has 3 steps. What's the first step I need to do? Yeah. Remember, we got to know which one's bigger, right? This is smaller than 0.05. So we're going to write that. That's called the linkage step. And so we're definitely going to have linkage. Boris, what's the next step in our conclusion? What do I say based on that? I am going to reject that null. Very good, because it's too small. It's small enough. And then, Karen, what do I do from there? And what would I say in this case? Perfect. That's exactly what you say. You want to say we have evidence to suggest. We can't say there definitely is. It's just based on my sample. But we have evidence to suggest there is a difference amongst the treatment groups. Excellent. We work together as a group really well, don't we? We can all put our little pieces in and we can get it right. It looks really good. Excellent. I'm about to blow your mind, okay? Because the calculator will do it all with just plugging in the matrix. What? Okay. It'll give you the expected matrix automatically. it will give you the chi-squared test statistic, the p-value, and the degree of freedom. All you have to do is be able to interpret what it means. I think hopefully we can do that. So go ahead and get your calculators out, and let me show you what I need you to do with it. Thought I had my calculator up here, but I don't. Let me get it back up. But get your calculator. Find where the matrix option is, and be careful because a lot of us came from different backgrounds. And matrices used to be done in Algebra 2. They're no longer done in Algebra 2. So this might be the very first time you've ever seen a matrix feature of the calculator. It used to be done in Algebra 1 many years ago as well. So if you haven't, depends on where you are and what teacher you had and whether you did this at all. Okay? But I'm about to show you. So the matrix key is second, and then right below it's above the x to the negative 1 power. So we're going to go to the matrix key. It's very important that you listen to this step. Everyone listening, look at me in the eyeballs. I need to see eyeballs to make sure everyone hears me. You do not want to stay in the names tab. That is when you do what are called matrix operations. We don't know how to do that. We're not doing that. What we are doing is editing the matrix. And for our purposes, I'd like us to stay in matrix A because that's the default of the calculator anyway. In theory, you could put it somewhere else, but just for our sake, to make things simple, let's just stay in matrix A, okay? We're going to edit matrix A, so we're going to hit enter. The default is this. A matrix has a size. In other words, it's called an order. It's called a dimension. It has lots of words. Just basically means the number of rows and columns in the matrix, okay? How many rows do I have? 2. How many columns do I have? 3. Notice, even if I entered it wrong, I could go and change it. Once I plug in the size, that's read, by the way, 2 by 3, kind of like a 2 by 4 if you ever go to Home Depot and look at wood. I don't know. Anyway, it's called 2 by 3, okay? That's how that's read. It means 2 rows by 3 columns. That's just the size of it. And it actually should look exactly size-wise like the matrix you have given to you. If you ever put it in the wrong way, it'll just look wrong. You just go back and change it. No big deal. I have a matrix that looks like mine. That's what I'm going to enter it in. This is my observed data. 24, 22, 14, 6, 8, 16. All I've done is entered the data. Okay? Now, to find my expected values, didn't I just sum my rows and divide it by the number of columns? Well, the calculator will automatically do that for you. Let me show you why. Once I've entered my data, I'm going to go to the test, because now I'm ready to do my chi-squared test. This doesn't matter if you're talking about homogeneity or what we're about to do in terms of independence. The chi-squared test is the first of the 2 that come up. Remember that we're not doing the goodness of fit, we're doing chi-squared. It's going to ask you, did you put your observed in matrix A? Yep. It's going to automatically put the expected in matrix B. Okay? Then we're going to come down here and we're going to calculate that bad boy. Did I get 8.4 as a chi-squared? Did I get 0.01499 as a p-value? Is my degree of freedom 2? Boom. Okay? Now, if I wanted to look and see what those expected values were, I can do that too. All I have to do is go back to the matrix, go back to edit. Notice that wasn't there before, that 2 by 3 in B, was it? But if I go down to B, mind blown. It's there, okay? So we're good. We know we did it right. On the quiz on Friday, I am okay with you obviously checking your work on the calculator. But I am going to ask you to write all the steps. I am going to ask that you show me the calculation of the chi-squared, that you show me the calculation and the drawing of the p-value, and obviously that you put the conclusion in context and show linkage. It's not that hard. I don't think it's that time-consuming. The only thing that's a little time consuming might be the test statistic. That's it. It's not going to be that bad. Okay? Feel okay with homogeneity? Not too bad, right? Remember, one variable, many treatment groups, or multiple treatment groups. Let's do the last example, maybe we will, about independence. Okay? So this is the last one. Last example we're going to do today. You ready? Without even writing any of this down at all, maybe. Why is this not? It's acting funny. Won't let me do a shade. Computer drives me crazy. Without even writing anything down, without doing anything, just kind of looking at this briefly, can you tell me, there we go, can you tell me why this is not goodness of fit? It's not one sample, and I've got two variables. What are my two variables? Gender and whether they favor gun control, right? So I've got two qualitative variables, gender and their opinion on gun control. And that's what I'm trying to see, are those two things independent of one another? Okay? Notice it actually says the word independent. It says the word independent, right? So we know we're going to do a chi-squared test of independence here. Before we actually jump into the test itself, I'd like to look at it from a probability standpoint first, kind of like they did on the Frappy from today. Okay? Let's look at the probability, this conditional probability of favors given that they're a woman. What is that probability? Tell me what I would divide by. What divided by what? Well, first, before I can divide by anything, don't I have to come up with my totals? All right, so let's do that first. Okay, so I have 100 men, 100 women, 90 favor, and 110 oppose. Would you agree? All right, so now let's figure out what I divide by. What's that probability? Favors given that they're a woman. What number divided by what number? Favors and woman would be 52 divided by the total of women, which would be 100, which is just 0.52. What about the probability of favors? Why would I be interested in comparing those two probabilities? We talked about it during flex today, because that's going to show me from a probability standpoint if they're independent or not. What's the probability of favors? The total of favors is what? 90 over the total, which is 200. Well, that's 0.45. Are they the same? They're not the same. They're not too far off, but they're not the same. Would you agree? So they're not super far, but they're definitely not the same. So from a probability standpoint, they're different. Would you agree? So from a probability standpoint, we would say, therefore, they are what? Independent or dependent? Which one? Dependent. They have to be equal to be independent. Okay? So therefore, they're dependent variables. That's from a probability standpoint, kind of like you did on your Frappy during flex today. I want to look at it thoroughly from a hypothesis test standpoint or from an inference standpoint, because this is really just a sample. And sample has variability. There's sampling variability from sample to sample to sample. So I really need to take my sample and use inference to make it about a population. So that's what we're going to do. We're going to do the chi-squared test for independence. Okay? Before I begin doing that, I have to figure out what my expected values are without doing it on the calculator. Can you do it without the calculator? Tell me what you think we should do. Without the calculator. Are you summing? Okay, you can add. I just added them for you. What are my totals here? I have 100 men, 100 women, 90 favor, and 110 oppose. All right? How do I find my expected? Think back to how we did it with homogeneity. Similar. Matthew? It's actually, we're going to look at the rows. Okay, so I'm not dividing by 4. I'm going to be dividing by 2. So it's going to be 90 divided by 2, because I've got 2 categories here, right? Which is going to be 45 and 45. Because that's 90 divided by 2. Okay? And then over here, I have 110. Again, still 2 categories. So 110 divided by 2 is going to give me what? 55. So those are going to be my expected values. Taking my row totals and dividing them by the number of columns. That's really all it is. Okay? Because we are expecting there to be no difference between men and women's position on gun control. That's the null hypothesis. There's no difference between them. Well, let's see if that's true. Okay? So, what do I have to do here? Well, are there any questions about how those numbers came up? Yes, ma'am. Rows, totals divided by the number of columns. All right. What's the null hypothesis? This is a test of independence, so we have to use the word independent in our null and alternative hypotheses. How do you think we should say it? Use our context here. What context do we have? Yep. So gender is independent. That's the null. They're independent. We're trying to show that they're dependent. So they're independent of opinion on gun control. What do you think based on, and by the way, the independent will always be the null, therefore always the alternative will be dependent, okay? So gender is going to be dependent, and I'm okay with you saying not independent. They mean the same thing, okay? There's your null and alternative hypotheses. You can say that too.
Wouldn't that change how that last statement means? Because gender is like your opinion of gun control.
You're right. It does. If you're right. That order does matter, doesn't it? Because you're not going to, if you're not born to, with an opinion on gun control, and then they decide whether you're a boy or a girl. That doesn't happen. You're right. So it has to be written a certain way. Kind of funny. You are against girl. No, I don't know. It doesn't work that way. All right. Skip step 2. We can't do that. So what is step 2? What am I doing here? What's the name of the test? Chi-squared test. Done. Just kidding. Chi-squared test of independence. And my 2 conditions. The first one. What's my first condition? Random or representative. Does it say that? The skeptic in me wonders, did they go to the NRA and ask this question? Did they go to Mississippi and ask this question? How about Texas? Who knows, right? When I went to Chantilly High School, we all had gun racks on the back of our trucks that we had to have ladders to get into. Just saying. I'm from the South, y'all. It's good. No, I'm just kidding. We don't know. I'm just asking you to be skeptical, right? And I don't know the answer to this. It doesn't say that it's a random sample, so we have to be careful. Okay? What we're going to have to assume, unfortunately, is that it can't assume it's random, but we can't assume it's what? We hope it's representative, okay? Not if it's at the NRA, right? That's not going to happen, okay? But we'll have to assume that it wasn't, but put your skeptical hat on. Condition 2, we can clearly say, what? Jenna, what can we clearly say about condition 2? What's above 5? Which counts? Which one of these counts? Right, so you have to just be clear that you say expected counts because they will deduct you. They want, because you have observed counts too. Just make sure you say all expected counts greater than 5. Excellent. Okay, ChiSquared. I'd like us to show it by hand. So you're going to, because you're going to have to do it by hand on the quiz, okay? You can check it on the calculator. But we're going to do 38 minus 45. Quantity squared divided by 45 plus. And go to the next one. 52 minus 45. Matt, did you have a question, sweetie? Oh, I just thought you were just stretching. Saw you out of the corner of my eye, my peripheral vision. Maybe it's going. 62 and 55. And then our last one was 48 and 55. Let's see how we did. The chi-squared value that I got was 3.95 repeating. How'd you get? How'd you do? Okay, and then the p-value, if we're going to go ahead and draw that, and we get 3.95 repeating, and we are looking at a chi-squared CDF with 3.95 repeating to some large number far off to the right. Our degree of freedom is 1. Because it's the number of rows minus 1 times the number of columns minus 1. 2 minus 1 times 2 minus 1, or 1 times 1 is just 1. I got 0.047. How about you? Something close? Okay. So that was step 3. Let's finish this thing off with step 4. Who haven't I called on yet? Noel. Haven't called on you yet. Give me my linkage step. What do I say? It is less than. Barely, but it is. Now, did we expect it to be kind of close? Think back to what we did from a probability standpoint. Were the two probabilities that we compared kind of close? They were far. It was hard to tell how close they were, right? They were not exactly the same, so we assume that they were dependent. Apparently, they're far enough apart that they are, okay? So we don't have super strong evidence because at a 5%, if alpha is 0.05 or a 5% significance level, it works. But if we had a 1% significance level, it wouldn't work, would it? So we have to be careful about that. All right, what am I going to do? Reject or fail to reject based on this level? Angelica, what do you think? I'm going to reject that sucker. And Jenny, tell me in context what I'm going to say. That they are dependent. Very good. Excellent. Gender is dependent. No. That opinion on gun control is dependent on gender. Definitely not the other way around like Byron suggested. That would be kind of funny. But that's true here. All right, good. So again, the process is the same for every hypothesis test. And actually, all the chi-squareds are really kind of the same. It's just a matter of whether I have one sample or two or how many variables I'm dealing with. But really, the process is the same. The calculation of the test statistic is the same. And it's just a matter of how to use the calculator. How would I use the calculator in this instance, by the way? Use the matrix again. Did anybody do that just to check it? Totally fine. You can go ahead and just plug in your original, your observed values into matrix A. Someone asked a really good question in my last class. Do I have to, didn't I just use my calculator? So do I have to go back now to matrix and take those out and delete them and start over? I don't. If I just go to edit, and I'm going to edit matrix A, and I just say, what size is my matrix now? 2 by 2. It'll just delete one of the row or one of the columns, and then you can just literally just write right over it. There's no need to do anything different. I don't make sure it enters at all. I don't have to do anything to matrix B either. It will automatically write over that as well. And at this point, I could just go to stat test and do my chi-squared test. Whatever it is. It's going to put the expecteds automatically in B. We'll check those. But isn't this what I got before? When I did it by hand, so I did it right, so I know I'm good. And then if I go to matrix, and I go down, hang on, I go to matrix, there we go, and notice I'm going to edit matrix B. It does put what we thought the expected values should be there. Question? Okay. All right, perfect. The last thing I wanted to kind of address real quick is what happens in this case. It's not a hypothesis test question, but it relates. And this data has nothing to do with what we just did. So those numbers, 40, 60, 30, are just made up numbers. But read the problem. So I have seen this come up on a multiple choice question before on the AP exam, at least on the release questions. They're asking you to figure out what number that should be. They're saying that if the two variables are independent, and that's pretty important information, if they're independent, what should that be? No? 70 you're thinking because they should add up to be 100, right? Okay. We're not looking for the numbers, the totals to be the same. We want the proportions to be the same. It is 20. Okay. So let's think about what that is. The proportions. Okay. So that means that 40 over 60 would have to be the same as what over 30? Remember this back from like Algebra 1 or geometry even? You can actually now cross multiply if you wanted to do it from an algebra standpoint. Or you could just know that 40 over 60 reduces to 20 over 30. Either way works. They're the same. Okay? I just wanted to show that to you because it comes up. Because 70 is a common thought. You want those columns to add to be the same, but that's not what it's asking. Okay, so 70 would obviously be a distractor in your multiple choice answers, right? So, okay, perfect. So what's due next class? The portfolio. And what do you have next class? Quiz. I told you about the format of the quiz, correct? The quiz is going to be 10 multiple choice questions and 1 free response question where you're going to have to do one of the tests from beginning to end. They're each this is worth 10 points, and this is worth 20 points. 2 points apiece. Okay, 30-point total. 3 of those multiple choice questions are going to ask you to identify which test to use. So you want to look at the scenarios on the just checking, the last 3 questions on just checking, and the first 2 questions in the back of the book. I'm sorry, on chapter 25, like the first problems 1 and 2 in the back of the chapter. They ask you to identify which test to use. Okay? All right, that's it. You can use the rest of